And we're live. Right. Welcome back to another episode of the Cycling Physios. My name's Tim. Bianca is hiding in the background tonight. She's monitoring the chat box. It'll just be myself and John on screen. And we are joined tonight by John Wiggins. And we're following on from our aerodynamics theme. We've had a couple of previous webinars talking about the background to cycling biomechanics in terms of aerodynamics and what aerodynamics is all about and testing for that. And John is now continuing our theme and looking at real world testing. And we're incredibly privileged to have John with us tonight because John has a wealth of experience working through 3 Olympic cycles as a sports scientist and cycling coach, and is now looking at real world cycling with Aerolab. So I'm going to hand the mic over to John to tell us a little bit more about what he's doing now and his background to how he's got to where we are now, and give us a bit more information about real-world aerodynamic testing. So, John, I'll add your screen, and you can take it away.
Yeah, I'll just enlarge that a little. Yeah, perfect. Okay. Well, thank you very much, Tim and Bianca, for the invite today to your webinar. It's always a pleasure to reach out and to support you guys with a fantastic initiative. It's also a pleasure to be able to speak about real-world aerodynamics, because that's really a passion and definitely the future where everybody's talking about a lot about aerodynamics at the moment. I've had an extensive career journey through cycling, working the last 20 years as at the highest levels of the sport, with over 12 years in Olympic cycles, so 3 Olympics for Belgium cycling. With a background in biomechanics and fluid dynamics, having worked at British Swimming. So yeah, this 20 years later, I came out of the federation and I worked after Rio for a performance cycling clothing brand in aerodynamics and bike fitting. And still working projects, consultancy projects in Formula One, motocross, MotoGP, equestrian sport, which is quite alternative in that aspect, and obviously cycling and cycling aerodynamics. And here are the topics that I wish to run through this evening, or wherever we are in the world listening to this. And for some of you, new ideas, and for I'm sure many confirmation of the way in which you work or wish to work in the future. So I hope I enlighten you on that and the ideas behind it and the technology and how far we are with the technology these days. And the future of cycling is continuously accelerating in both innovative manufacturing through R&D and to establishing more accurate training tools and training methods with more and more skilled experts coming on the scene. So that's also very exciting for the sport. So these are exciting times ahead for aerodynamics, and we will cover the following. So where is the aero trend steering towards a golden standard? That's what everybody tries to strive for. Where is the golden standard in real world aerodynamics, which is all pretty new for everybody? Who benefits from this type of tech, and limiting factors, control the controllable. I always say repeat the repeatable. That's very much common sense throughout all types of testing, whether what field testing, physiologically testing, or whatever, in sports science, and embracing new patent technology led by world-class university research. So yeah, like I said, it's exciting times. Moving on, what and who is setting the trend, and there is a lot of competition out there at the moment. But what we try to establish this evening is a little bit about who's doing what, and what we can take out of it from ourselves as bike fitters or aerodynamicists or physiologists or biomechanists. So it's testing, either indoor lab testing or outdoor field testing. Repeatability and consistency using accurately calibrated tools is key to successful test results. Estimations or assumptions are not repeatable. So I'll take you quickly back to 2011, when the patents finished with SRM, and along came many competitive power meters onto the market, or statistical algorithms, estimators on the market that were cheaper. And basically, they threw away the principles of retesting and day-to-day accuracy and power data. And price over accuracy in marketing won hands down, and still does. Maybe changes are again on the horizon, but there's more to come on that, and definitely we'll touch a little bit on that on these slides. This is true also, but somewhat in the reverse, with mobile aerodynamic tools. And what I mean by that is, firstly, many gadgets have entered the market, either as timing systems or estimation devices. So it's very important to understand what you have in your hands to quantify as a test as accurate, reliable, repeatable, and consistent instruments. So power is a dominating factor in any aerodynamic equation. So the more accurate data that we can acquire, and the more repeatable accuracy at high speed will determine how granular adaptations to aerodynamics you can analyze, basically. So here you can see, for example, here are a couple of slides that we will go a little bit deeper into, and you can see very clearly the raw data on the left side and how the process data is, and the accuracy and the wind speed, wind yaw angles, and the type of speed that the rider is riding at, the power that they deliver, and then at this point of time is a process data of CDA. So moving on. This is the accuracy of the data acquisition is reliant on the high-speed sampling signals of the measuring instrument. So when we focus on the air resistance as a dominating force factor in cycling, then we see that every part of the formula is crucial in interpreting consistency in data. So it goes without saying that instruments that only measure half of the equation, or instruments that can't process a high sampling rate, are limited in the understanding of any granular analysis or small changes such as helmets, fabrics, body shifting, any cockpit instability or stability, and comprehending sustainability over time and estimated energy consumption gains and losses. So it is definitely an area that, from the standpoint of technology, so it's Aerolab, they are very keen to implement and show off this technology, because it's been a lot of credit to a lot of the team, how they've developed this over a few years of extensive research and work, and being able to plot this, bring this all into one very smart, small little instrument that works very, very closely and cleverly and calibrated from a wind tunnel. So your energy efficiency is determined by, and we speak always about shape, form, and power. Obviously, power always has to be in the equation. And basically, we always say that you can't buy a helmet or suit to make you faster, a fast helmet or suit. However, you can optimize your shape to make the helmet and suit fast or faster for you. So for every bike fitter, physiologist, physiotherapist, coach, biomechanist, aerodynamicist out there, there are several common areas of importance in understanding performance over comfort. And this is currently still a massive void between expert labs, wind tunnels, velodromes, where the athletes are positioned into an either extreme unsustainable position or unstable, uncomfortable position. So the equation of power, this is a dominating factor for efficiency. And the objective is to overcome the resistances with more effective shape that both has power, comfort, and ultimately going faster, further, and longer. So playing with shaping riders, cutting them out, placing them in CFD models, power acquisitions, and then replicating this in velodrome conditions have all become the norm in trying to replicate the ultimate performance outdoors. However, the real world still complicates these CFD modeling or computational models with many variables such as CRR and yaw, which are quite often not in the equation or taken out of the equation just from the variable complications that there are. So we see that molding your body to manage the performance is super important, and we see the athlete has three big tasks basically on their hands to overcome variable resistances, and there's working together with their bike fitter and physiotherapist to complement their shaping and form, basically becoming slippery. What we see as slippery, very easy in fluid dynamics to understand that, and obviously there comes an added accent of buoyancy in fluid dynamics, which is totally different, and an oxidization. and the way that the athlete sits and slides through the water. But we do see that also, and we like to comprehend and use the terminology slippery also with cyclists, because there are cyclists that can mold their bodies very small, very narrow, and some are more natural than others, more stable than others, more sustainable in focusing long durations, staying still, and still obtaining a massive performance output at the end of the day. So these are key points basically that I've worked on over many years, and they are valid points that always keep coming back now, even when we see this technology that's coming onto the market with such high accuracy. So basically, this is 8 tips in aero for understanding your athlete's sustainability, whether it's in a controlled environment or even more so going outdoors in the real world. As further, faster, forever, we always say that the 3 Fs that are what we're trying to realize as an adaptation in the athlete. So the number 1 is definitely performance efficiency. At the end of the day, we want to ride bigger gears. We want to go further, faster, with more energy saving, so lesser CDA or lesser resistance. The comfort and the pressure are super important, but are outweighed by performance at the end of the day. So even though the athletes are quite often not so comfortable, a big difference between somebody that's doing a 4-kilometer team pursuit that's 70 kilometers an hour from a standing start, or somebody that is on an Ironman Hawaii, for example, that comfort obviously comes into a different role play. But balance, stability, fixing the hip angles and fixing the hip position is super important. And you see that with manufacturers, how they design their frames, the steepness of the frame, how they position the angle of the hip. And then obviously gravity and the center of mass in the body position, how the rider is balanced with his proportion of weight and balance, and how he creates a light weight basically with lesser pressure in the front end of the bike. Stability and symmetry play a massive role in anything with biomechanics and aerodynamics. Effectiveness of basically all the above. I've done them a little bit in the order of the ranking that I see it, and then bringing that across as a torque. So torque is crucial in understanding that we don't have any torque losses because of impingement areas or areas where the rider becomes restricted. And then basically the 2 E's, the energy efficiency and gains and losses in watts. And that is basically what I see as my top 8. I always call it top 8 because we work in Olympic cycles. The top 8 athletes is in the Olympics is super important. That's yeah. So I try to steer with that with the 8s, and then with accurate data acquisition, real world aerodynamics is a very sought after means of validating equipment. So with high-speed instruments in aerodynamics, this is opening doors for manufacturers, fitters and pro teams, federations to assess and validate how equipment is interpreted in the real world. This is complicated material, and highly regarded engineering data companies are joining together to complement each other, such as high-speed power meters, aero instrumentation, in supporting how either rider or equipment performs in the real world. And you can see here I split it up in 3 main topics, and that's how we see it as a manufacturing company in aerodynamics, is that basically we see manufacturers as a separate identity in aerodynamics, fitters and teams and federations. Now, obviously, the teams and fitters and federations, they collaborate quite often. Manufacturers, on the other hand, have quite often, until now, listened to fitters and teams and then adapted their products. We see now with the technology how it is now, that definitely towards rolling resistance, types of tire compounds, the wheels, the compatibility with the tires, the frame, the designs of the frames, the clothing, helmets. This type of real world is such an important validation for making any future or development of R&D within the manufacturers, actually going with new products and actually being able to prove to the teams and federations, this is the direction we wish you to go in and not the other way around. So yeah, that is for fitters, obviously an optimal biomechanics, a stable cockpit, sustainable positioning. Lower is not always faster, so we're talking about efficiency. breathability, breathing, how restricted you are in the way that you can breathe, hip impingements, obviously hip angle restrictions, pedal setups, which is complicated, shoe and foot stability, hands and forearms, super important, head positioning, obviously. So a lot of topics, a lot of areas with this type of real world technology that with high speed sampling, sample rates, that we can actually see that and evaluate that. So this, what I always say is failing to plan is planning to fail. We have three main areas of implementing successful real-world testing, and that is basically over equipment, test protocols, and being prepared to record. Are super important, as anybody in the field, anybody that's a bike fitter, anybody in specifically in aerodynamics, these type of field testing. So you really need to know what you have, like I said, in your hands. The engineering grade that you have, the pattern, the technology, the reasoning behind it, the research, and that it's wind tunnel calibrated, so you have your accuracy. The high sampling rates, so we're sampling with an Aerolab, for example, anything more than 40 hertz, with all the different sensors. Yeah, basically a little bit restricted at the moment how power meters are working. So they're working anything from 1 hertz to 4 hertz. So you can see that the sampling rate there is a lot lesser. And like I said, there are companies jumping on board basically for introducing their new high frequency sampling rate power meter. And then obviously being able to measure yaw and the CDA and the rolling resistance is super key in such an engineering grade instrument. And then test protocols, basically controlled safe test area, repeatability, consistency, and engineering support. And being prepared is super, super important. So any bike fits has to be done, and the physiotherapist, so you understand if you're symmetric or where your asymmetry is, tire pressure accuracy and the rollout, with the weather conditions, obviously, and the air density, then how you're going to record, and obviously then the small things like battery replacement, so you're never stuck, and the test can be brought to its end and completed successfully. So this is a little bit of an idea, and give you, it's quite a broad look onto how we see that power is, the powerful knowledge of correct measuring is super important. With reference to this CSV file is how intricate work the technology handles CRR, air densities, accelerations, GPS, and basically equaling to, at the end, a CDA. And all that credit really goes to Professor Chris Morton as an aerospace engineer, that he's done the groundbreakingly work and co-founder of Aerolab Tech. And they did a lot of their research work over the last 3 years, and their patented technology of being able to equate basically for the CRR and the yaw angles into this small instrument has offered not only leading cycling teams, but federations, manufacturers, leading aerodynamicists, but also automotive manufacturing. So to acquire the technology for real world aerodynamics. So it's, you can see it's in a very extensive and very broad look on and an intricate way of working, and how many different data files are actually, the acquisition of data coming into the unit is amazing. And this will give you a little bit of the idea of the R&D pioneering and validating changes that we have in the market today, and companies that are reaching out, and we're being able to confirm and validate and work together. And you see that UCI World teams also, they like to be in their comfort zone. So that's a good thing, because a controlled environment, they already have a lot of data. And that's basically continuing their controlled environment testing. But with that data, then very cleverly then going outside, keeping testing within their comfort zone, knowing exactly what they've been doing, and then being able to take that data and go further in outdoor and validate that. So we've seen some very smart development opportunities and projects within the World Tour teams at the moment. There's a lot of brainstorming going on, and especially with federations coming up to the Olympics, and making the difference with quantifying their database in the real world, basically. race recons, positioning or equipment changes, restrictions within the sponsoring that they have. So they have to, quite a lot of the teams, quite a lot of the riders have to make the most of the type of helmet that they're working with or the type of suit. So they really have to learn to make that product faster for them. And all those changes that go on during a season that's very complicated logistically for a team. So nothing is taken for granted anymore with this type of tech in-house that they can use worldwide wherever they are. They have the technology with them, and they can, like I said, do the race recons or check areas of equipment. If they say, look, we don't trust this type of wheel setup or this helmet, can we change? And what is the best setup for this type of air density? So yeah, there's we can see that more and more that consolidating the engineering greatness, basically what we're achieving in this technology, and being able to demonstrate that and show that off with the teams that are pretty wide-eyed and wowed by what incredible technology and data that they're being able to achieve now with accuracy. So this was a little bit of an example I gave from a velodrome test example to show you the power of such technology in the real world. Firstly, going to a team within their comfort zone and expressing, yeah, they made some small changes. For this one was a good example. They only changed the pads and narrow 3 centimeters, even though the CDA outcome was not so bad. There was a note that they were shifting quite a bit on the saddle. The rider was not so comfortable. So we made some changes basically, and we changed the pads, and we went 3 millimeters higher, and they kept the bars at the same angle, and the CDA dropped to 0.202. And then what was interesting was they tilted the bars because there is a trend that the riders want to get behind their hands, and they put a 7.5 millimeter spacer, the bars, not the pads, but under the bars, and lifted the whole front end up, which when you see the measurement, then it's actually increased 0.204. So yeah, it was intriguing to see that, and we quickly made a smart adjustment knowing that. We took the spacing out from under the bars, and we put spacing in between the pads and the bars. So we lifted just the front end of the rider. We didn't move the whole section. And we opened the hip angles of the rider as well, and actually created more comfort, more power, and he dropped under 0.2 as well. So that was an intriguing one. And the team then, they like challenges. The team then, they throw at you ideas, and we knew the baseline then from that rider, so we used the same baseline, which you can see as the blue line in session 6 as his final TT position with the aero helmet. And we went into same position, but remove helmet from the visor. And then in the same position, but with a standard road helmet and glasses. And then you can see very easily the differences in CDA value. So that was impressive to be able to see that those granular changes. And we can then bring that very smartly to outdoor to confirm that. And then also the team, it's a complicated process, because obviously you come outdoors and you have different wind speeds, you have wind yaw angles, which are playing a different role on the instrument, on the way that the rider works. And we execute some out and back testing, or we can execute a free ride where they ride from A to B, but preferably out and backs until they get used to protocols and they become very consistent. You see with this rider here, from laps 3, 4, and 5, he became very, very consistent with his CDA, with his power output and speed as well. So that was the riders, they start to learn how to use the equipment correctly within different wind variables. So that was, 1 second. Yep. Okay. So yeah, smart and exciting times ahead. Also, to look out for the different opportunities. There will be a lot more media opportunities with more aero courses. There will be opportunities also to enable a fully fledged member of becoming a part of the IBFI, International Bike Fitters Institute, as an aero expert fitter. So yeah, there are going to be lots and lots of opportunities to experience and be able to work and learn to work and be driven and steered by our engineering team to become an expert in the field of aerodynamics outdoors. So yeah, this gives you a little bit of an insight of where we are today, and we can definitely learn more and become an expert in real world aerodynamics and cycling. That would be a fantastic goal, to see a lot more people coming on board and exchanging ideas and becoming a very smart community together. So that was, yeah, thank you very much. That was a quick introduction through what we are doing and how we are busy in the real world aerodynamics. And yeah, we can go over to questions and answers, I think.
Excellent, thanks, John. I'll just take your screen back down again, back just to you and I. Yeah. So yeah, that was very interesting to see how obviously technology is moving on, and I mean, that's something certainly I've seen in the coaching world within even just age groupers is, 2020 was an opportunity for a lot of people just to really geek out on trying to improve positions. When they're not racing, there's been a lot of investment in other ways to find that almost free speed, isn't it?
Yeah.
So from our point of view as bike fitters and maybe sort of physios in the bike fitting world, is how do you see us maybe applying this in our bike fitting process? Where do you see that kind of that role for maybe making some changes, send them away, test that, come back? How's that work in your world?
Yeah, I think it's a good question. I think it's a very smooth transition, actually, because of the user-friendly application. I think that is super important, that you can make small adjustments. You can confirm that indoor on your testing, that your established test protocol that you do now, and you can go outdoors and see the sustainability over time, to see how comfortable they are in that position. And then you can either work on the body dynamics, the way that they have become more flexible, can mold their body into a better shape, and then come back and then have a better referral in the way that they can improve their positioning. Or maybe they are sitting already optimal, and there's also possible. Maybe they've had a crash and they're a little bit asymmetric, and they should be a little bit tight on one side, and being able to loosen up and changing, or if they want to change, if they're changing crank lengths, for example, and they want to validate that and see how much more efficient they become, and if they have a better CBA and a more open hip angle, for example. Quite similar to how we showed that the bike fitter can confirm that and can see that in any power gains or losses. Yeah, so that I think there are some fantastic opportunities there. I think that you've basically from going from a lab and being confirmed indoors and seen and getting that data from outdoors in the real world, I think.
Yeah, that's it. It's the applicability of this, isn't it? And it's all very well having this very clean, clinical, lab-based data, but exactly as you were saying in your talk there is when you start throwing in all the real-world environment stuff, it can get very messy.
Yeah, sure.
What do we then sort of test on rolling roads, or do you try and get somewhere very, very flat, or a standard gradient or consistent gradient? What kind of surfaces do you tend to try and use in the real world?
Yeah, again, that's complements to the technology that you have in your hands, because it's very dependent on how the technology can handle that. So, for example, that with an Aerolab, we have a very high engineering grade GPS system. It's not a standard GPS that you would have in a Garmin, for example. So with that high engineering grade of instrument, we can have rolling terrain. For example, we tested with a World Tour team, and we had some bridges in their loop, free ride loop that we were doing on their aero testing. And it was very clear. We had a yaw angle, and on the bridge, we could see the CDA dropping. And this was just purely because of sheltering. So the lower part of the body, the lower limbs were not in the calculation. And so just to show you, how important it is to actually understand where you're testing your test location, and the effects on that terrain as well. But yeah, we can. It's not an issue for terrain or being able to test in any type of. Well, I wouldn't say, as long as the speeds are above 15 kilometers an hour, we can test anywhere basically. Yeah.
I suppose that somewhat links into a thought I had with that previous question, which is that bike fitting is very much of an evolving process. We're not trying to get someone in just a position and that's it. See you later. You can stay like that for however many years. It's about continually monitoring, adapting, changing, and reacting. Do you then see maybe differences in terms of what you're looking to achieve depending on race terrain and race courses? How are you using it for that?
Yeah, because everybody's individual. It's very much an opportunity to see how stable and how sustainable the rider is. And then you can start to work on more granular aspects. So in the way that is the helmet, can we change to a smaller helmet? How much movement does the rider have in his head? Is he moving around a lot when he's riding? Is he putting his head down, which is quite a lot of a trend at the moment? So definitely a shorter helmet is then better. So these type of aspects, is it what type of air density is it? Is it for a short sleeve skin suit, or is it a long sleeve skin suit that they need? What types of speeds are they getting up to in the terrain? And then it comes down to also tire pressures, rolling resistance, the type of how compatible the wheels are in the frames of the bikes. So that's there are always lots of different choices that have to be made within that. So it is a complicated topic.
Yeah, absolutely. So I suppose as we're thinking about this real world field testing versus maybe our more traditional wind tunnels, is this the end of wind tunnels? Are we moving away from that, or do you still think that we will see a blending of the two methodologies there?
Yeah, absolutely not. In actual fact, I think it's very complementary, because all our systems are wind tunnel calibrated, and Professor Chris Morton manufactures or builds wind tunnels for research. So we see wind tunnels very much as the start of any R&D project. And that means anything from fabrics, helmet designs, manufacturing, frame manufacturing, a confirmation basically of the CFD modeling that the manufacturers bring on. And then what is super, super important is the next transition, which at the moment there's a large void. And that's where we're trying to educate, and that is bring all that data, all that understanding and science into the real world. So that's, great. It's fantastic opportunity for all around, even the controlled environments in the velodrome. The Aerolab Tech, for example, has a velodrome mode. So there are many, many opportunities there. If you have, for example, very windy conditions, or it's really very, in Holland, for example, Holland has a lot of different wind variables, which could make it a bit tricky for testing out. So velodrome testing is a controlled environment test that was very, very interesting. And then taking that understanding of that to the outdoors and very extreme wind variables, and seeing the yaw and how either the bike or the rider is being pulled by the yaw as well. So that's an interesting one.
And that comes back to your points around stability as well.
Absolutely.
All very well having a beautifully aerodynamic position in the wind tunnel, but if you can't stay stable when you're getting buffeted by side winds, then again it's not going to stand up, isn't it? So with all this data that we're getting from the tech, how much do you still use either a Mark 1 eyeball and just looking at the rider, or maybe using video footage to support some of your decision making? Do you still use this? Yeah,
I think that it's always important, because you have the mental aspect with the riders. So it's a very similar one to riders have a tendency to like certain helmets, they like the look of the type of visor that they have, and be able to hide behind that visor. It's quite intriguing to be able to show them sometimes it's actually faster with just your sunglasses than a visor. But yeah, that's so. I think it's good. It's not something to throw away. Video analysis is always very interesting, and we've been looking into that to be able to collaborate and introduce that a little bit like a dartfish system where we do have the video or the photos next to it. I think that's very important for bike fitting. That's not initially on our priority list.
Yeah.
It could be down the road if the demand from the fitters say that they really need that. So yeah, I don't think, I'm never one for throwing anything that we've used or confirmed away. I don't believe in that. I think it's just adding to the expertise and the skills of everybody. Yeah.
That's it. We've still got to blend the art and the science, haven't we? And we're bringing more and more science into the equation. But there is still the art element. And like you just said there, it's the psychology of the rider and being able to read maybe even the sort of, the comfort level and psychological state of the rider in those different positions, isn't it? So, yeah, absolutely. I'm just looking to see if we've got any more questions coming through. This was one that came through on Twitter, quite a simple one that Bianca's just put in the link there. So what's best, lower or narrow? Obviously, I get a lot of people coming to me for bike fits and they're like, I want to go low. And we often need to try and educate them. That's not always the case, which is what you said in your presentation. But do you want to expand on that one?
Yeah, I think it's a good example that I gave. We went narrow is always better in aerodynamics, obviously, unless you come down to tire. But that's to do with that's a patch, and that's different than rolling resistance and pressure. That's totally different. But in the way that the body and the body shape and what I mentioned about being slippery, obviously frontal area is super important, and it's not always lower that's better. So yeah, that's it is an easy one. And I think that it's true to word with Dan Bigham, for example. Dan is pushing harder in his development, and when you see the bars, they might not look the nicest, but definitely when it comes down to CDA, being narrow is better. Yeah.
And as you said in your presentation as well, it's the body has to be able to become slippy or slippery itself.
Sure.
So it may well be that you have a position you would like to achieve, but that may take months, if not even years, to adapt your body into it. I mean, I've got a chap that I've been working with for the last few years, an Ironman athlete, and it is taking us years to train his body to get into the position that he would really like to be in.
Sure. I'll just put my lights on a minute. Be you better.
Yeah.
Yeah.
So another question just come through there. So what are the general aero trends right now? You touched on this a little bit, but do you want to maybe sort of summarize where you see things going at the moment?
Yeah, I think we're very dependent in manufacturing from aerodynamics. We're very dependent on power meters. So the more accurate high-speed power meter that we can use, the more we can do with the data acquisition. So sampling, high hertz sampling rate, for example, on track on the velodrome now running into Tokyo, super important for the sprinters, and even more so now in a way for team pursuit because they're up to such high speeds. So the power meter is obviously crucial for that. That is the trends that we see are becoming narrower. The way that we're measuring, I think that we're going more and more towards this type of technology, with even more better high-end engineering grade technology that's implemented in that the way that we measure aerodynamics and wind speeds and yaw. So I think that we, at the moment where we are with fabrics and aerodynamics, I think we're quite limited. I think there's still some fantastic work that's being done, but I think that what we've seen with the suits, even from 2012 with the British team, right the way through to 2016, and how those suits were then from the track brought into time trial, on the road was. I think that's a good thing. Helmet design is also another big one, because it's very, very individual on how they use that helmet to make them faster. So yeah, it's manufacturing, frame manufacturing. That's the intriguing one. I think there's still a lot of work to be done with that. So
yeah, absolutely. At least in sort of my world, the sort of triathlon side of things, there's a little bit more ability to adapt and play and not be restricted by UCI.
yeah,
Great. That's been a really interesting talk. So thank you, John, for developing this theme that we've had going on recently. Do you want to just share where people can find out a bit more about Aero Lab and maybe a bit more about you, your sort of social media or your websites?
Yeah, it's quite easy with me. It's Coach Wiggins. I think I'm on Twitter, on Instagram. If anybody wants to see some of the wacky ideas that we play around with and do in testing and field testing, and then obviously in LinkedIn as well. I think it's also under Coach Wiggins or John Wiggins. Then again with Aerolab Tech is just aerolabtech.com or .tech. Sorry. Yeah, and there it's important for also to have a look and run through the YouTube films. We have quite an extensive YouTube channel, and there you'll be able to see all the types of testing that you can do and how the field testing, and run through all the protocols basically that we do, and the design of the technology, the background, the co-founders. Yeah, so there's that's on the Aerolab Tech on the YouTube channel.
Great stuff. Thanks very much. We'll stick some links in the descriptions box for this video later on as well.
Yeah.
On our social media. Right, I think that's all our questions we've had come through. So I just want to say again, thank you very much for giving us your time this evening, John. It's good to catch up. I haven't actually since all the COVID kicked off. It was summer before that, wasn't it, when we had you over at the university?
Yeah.
Our conference. Yeah, blimey.
Yeah,
good to actually talk again, and look forward to seeing more from you over the next sort of coming months as we're heading out towards the Olympics.
Yeah, no, great stuff. Thank you very much for having me on.
Thanks so much, everybody, and please make sure you subscribe to see our next videos coming up. I think we've got another one coming out in another couple of weeks' time, so Bianca handles most of our social media, so look out for the posts coming from her. Okay, thanks so much. See you later.
Thank you. Bye-bye.